So, my name is Mehul Bansal and I'm here to give a review on paraphrase identification. My registration number is 20BCE1220. So, paraphrasing. Starting from what is paraphrasing? Paraphrasing is just restatement of a text or passage or work giving a meaning in another form. It's just rearranging the text to give it a different meaning. So, what is paraphrase detection? Paraphrase detection is the task of examining two text entities and determining whether they have the same meaning or not. In order to obtain a high accuracy on this task, thorough syntactic and semantic analysis of two text entities is required. Here, syntactic and semantic analysis are the models of natural language processing. So, what are the processes involved in paraphrase identification? First, we take two sentences and we do the following processes such as tokenization, stemming, lemmatization, feature extraction, similarity analysis, similarity report, etc. So starting from tokenization. Tokenization is generally an early step in the NLP process, a step which splits longer strings of text into smaller pieces of tokens. Large chunks of text can be tokenized into sentences. Sentences can be tokenized into words, etc. Further processing is usually achieved after a piece of text has been properly tokenized. So tokenization is nothing just like big chunks of text divided into small sentences, and then sentences are further divided into words, etc. And then moving to stemming. Stemming is the process of discarding affixes from a word in order to gain a word stem. So stemming is just removing prefixes and suffixes from the word to get the stem word out of the main word. Uh, the main words are tokens here. Lemmatization. Lemmatization is a process of grouping together the inflected forms of a word so they can be analyzed as a single item, identified by the word's lemma or dictionary form. Here we get the word's lemma or the dictionary form of the word. Feature extraction is when we use that different machine learning algorithms that learn from a predefined set of features from training data to produce output for the test data. Here we use machine learning algorithms on a training set of data which gives output on a test data. But the main problem in working with the language processing is that the machine learning algorithms cannot work on the raw data directly. So we need some feature extraction technique to convert text into a matrix of features. Now similarity analysis. Text similarity is to calculate how two words or phrases or documents are close to each other. There are a lot of techniques to calculate text similarity, whether they take semantic relations into account or not. Some of these techniques are Jacquard similarity, cosine similarity, k-means, latent semantic indexing, latent direct allocating, or any other distance algorithm like Jacquard. So similarity analysis is just when we take two pieces of text and we calculate the distance between them. Like if two words are very similar, they mean the very same thing, the distance will be very less. And if the two words are very different and they mean totally different things, their distance will be very apart. Here, if two words are totally different words with same meaning, we have to use semantic relations. Similarity report will show all the details of the paraphrasing, how much the content is paraphrased, and the percentage of plagiarism in the document. Now moving to syntactic analysis. Syntactic analysis or parsing or syntax analysis is the third phase of NLP. The purpose of this phase is to draw the exact meaning, or you can say the dictionary meaning, from the text. Syntax analysis check the text for meaningful comparison to the rules of formal grammar. The output of syntactic analysis is often represented as parse trees, which shows the hierarchical structure of the sentence. This is a key step in natural language processing and is used in tasks such as machine translation, text summarization, and question answer question answering. Here's an example. The dog chased its prey. The canine pursued its prey. Here the dog is replaced with the word canine and chased is replaced with pursued. Both has the same meaning. So hence both these sentences are the same but with different wordings. This can be analyzed using syntactic analysis. Syntactic analysis is important in paraphrasing because it allows for the preservation of meaning while allowing for the flexibility in wording. Here the meanings are same but the words are different, which is useful in text summarization, question answering, and machine translation. Now, semantic analysis. Semantic analyzing the meaning of the words and sentence in a text. This involves not only identifying the individual words but also understanding the relations between them and the overall context of the text. Here, there are different sentences such as the cat chased the mouse. The mouse was chased by the cat. The cat ran after the mouse. Pursued by the cat, the mouse fled. The mouse was chased by the feline. Here, all the five sentences have the same meaning, but these are totally different sentences with totally different form of grammars. Here, a cat can be object in one sentence, but in another sentence, a cat can be subject. And there are different participles of verb used. So here all five sentences have different uh, wordings but same meaning. This can be here POS tagging can be used. Sentence transformation. Using sentence transformation, we can paraphrase this sentence into several different ways while retaining the same meaning. The meaning of original sentences retained by the wording and structure have been changed to create a new sentence that conveys the same information. By using semantic analysis to identify the key components of a sentence, we created a variety of paraphrases that are both accurate and diverse. Here we are telling how the paraphrasing works. So paraphrasing works on the principle of sentence transformation. Here, uh, same sentence is represented in different words while retaining the same meaning. Here we use a semantic analysis to identify the key components of a sentence, and hence we generate a variety of paraphrases. Textual entailment. Textual entailment is a natural language processing task that involves determining whether one piece of text, known as premise, can be inferred from another piece of text, known as hypothesis. It's just comparing two sentences. Here, one piece of text is known as premise, and another piece of text is known as hypothesis. If hypothesis and premise are both equal, they have a very less distance, then they are paraphrased. The task of textual entailment is to determine whether the meaning of one text is entailed by another. Textual entailment can be used to determine the validity of argument, the correctness of statement, or relevance of the information. We have used several data sets like Quora question pairs, Twitter, PPDP corpus, Microsoft Research Paraphrase corpus, Machine Translation Metrics Paraphrase corpus, PPDB Paraphrase database, Wiki Answers Paraphrase corpus. These are the few references we have used for while making the paraphrase identification tool. Thank you. So few of the datasets we have used for training our model is Quora question pairs. So Quora released a new dataset in January 2017. Dataset consists of over 400k potential duplicate question pairs. Twitter PPDB corpus. The initial corpus contained around 51,524 human annotated sentence pair, 42,200 for training, and 9,324 for testing. Authors have released over data collected over 1 year, which consists of 28,69,656 candidate pairs. Then the Microsoft Research Paraphrase corpus. This dataset contains about 5,801 pair of sentences with 4,076 for training and remaining 1,725 for testing. The training set contains 2,753 true paraphrase pairs and 1,323 false paraphrase pairs. The test set contains 1,147 and 578 pairs respectively. Machine translation metrics paraphrase corpus. The training set contains around 5,000 true and 5,000 false paraphrase pairs. The test set contains around 1,500 and 1,500 each, respectively. The test collection from the banned 2010 paraphrase Plagiarism detection computation was used to generate the sentence level PAN dataset. PAN 2010 dataset consists of 41,233 text documents from Project Gutenberg, in which 94,202 test cases of plagiarism have been inserted. The plagiarism was created either using an algorithm or by explicitly asking Turkus to paraphrase passages from the original text. Only the human-created plagiarism instances were used here. To generate the sentence-level PAN dataset, a heuristic alignment algorithm is used to find the corresponding pair of sentences within a passage pair linked by the plagiarism relationship. The alignment algorithm utilized only bag of words overlap, the length ratios, and no empty metrics. For negative evidences, sentences were sampled from the same document and extracted the sentences pairs that have at least 4 content words in common. Then from both the positive and negative evidence files, the training set of 10,000 sentence pairs and a test set of 3,000 sentence pairs were created through random sampling. PPDP, the paraphrase database, contains more than 220 million paraphrase pairs, of which 73 million are phrasal paraphrases and 140 million are paraphrase patterns that capture syntactic transformation of sentences. Wiki Answers Paraphrase Corpus. The Wiki Answer corpus contains clusters of questions tagged by Wiki Answers users as paraphrases. Each cluster optionally contains an answer provided by Wiki Answer user. There are 30,370,994 clusters containing an average of 25 questions per cluster, which comprises of 11% of cluster having an answer. Now moving to references. These are the references we have used for the project. First was semantic similarity based on corpus statistics and lexical taxonomy by Jiang JJ. Then learning text similarity with Siamese recurrent networks. So here they have used this Siamese CNN model for learning text similarity, multi-perspective sentence similarity modeling with CNN. Then predicting the semantic textual similarity with Siamese CNN and LSTM. Siamese recurrent architecture for learning sentence similarity. The latent semantic analysis theory of acquisition, induction, and representation of knowledge. Exploration in context-based words, sentence discourse process, n-gram similarity and distance, in string processing and information retrieval, bit text maps and alignment via pattern recognition, computational linguistic, and mining the web for synonym, PMI IR versus LSA on TOEFL. So as you can see that most of the research papers have used Siamese network on a CNN model. So hence we are also using the same thing. Thank you.